Hi all. Today we will be discussing about the generations of cellular communication. First, we can have a look at first generation cellular system which was designed in late 1960s. Even if the first generation technologies was introduced in 1960, it was commercially deployed in 1980s. The first commercial system in United States was known as Advanced Mobile Phone System, which is also known as AMPS. AMPS was operational in 1982. AMPS was a complete analog system which support only voice calls. In first generation cellular communication, analog signals are transmitted by modulating them to high frequency carrier signals. In a complete analog system, it is difficult to send SMS or transfer data services. First generation cellular communication technology is also known as 1G networks. The main features of 1G networks are it supports FDMA, frequency division multiple access. Second one is it is fully an analog system. The final thing is it supports basic mobility. The main disadvantages of first generation mobile systems are poor voice quality, poor security, battery life is very poor, the cell phone size is comparatively very big, large in capacity, poor handoff reliability. The image represents basic first generation mobile handsets which are comparatively bigger in size. In a first generation mobile communication technology, the available frequency spectrum was split into a number of subbands which we call as channels, and each channel is allocated to a particular caller. Each channel is allocated with a 25 MHz frequency band for the signals to be sent from the base station to the handsets, which is called as incoming signals. Another 25 MHz band for signals transmitted from handset to base station is allocated, that is called as outgoing signals. In the figure you can see a 1G frequency band is split into 5 subbands. Each channel is separated from the adjacent channel by a spacing of 30 kHz. That spacing is known as guard band. The use of guard bands was one of the causes of inefficient spectrum usage and resulted in the reduced number of simultaneous calls, and this problem was overcome in the subsequent generations of technologies. One of the main advantages of first generation system is that it supports FDMA. By using FDMA technology, a channel used by a caller can be allocated to another caller immediately after disconnecting the first call. Another advantage is that the same frequencies can be used in non-adjacent cells. As you can see in the figure, the gray cells use the same frequencies and is non-adjacent to one another. Next, we can see what is handoff in mobile communication. Handoff is the process of changing the channel associated with the current connection while the call is in progress. Handoff can happen in two cases. One is crossing the cell boundary, and the other one is if the quality of the signal in the current channel is very low. These are the various 1G standards First one is AMPS, which is used in USA. Next one is NMT 450, which was used in various European countries. And the last one is TAX, which is used in United Kingdom.
Next, we are moving on to second generation or 2G technology. 2G technology is introduced to overcome the limitations of 1G technology, such as small number of simultaneous calls, large number of call drops, expensive due to inefficient use of bandwidth, and the 1G technology is not capable of providing caller ID or SMS services. 2G is an extension of 1G system. 2G technology works based on GSM, that is Global System for Mobile Communication Standard, which was commercially deployed in 1992. GSM supports high quality voice call and support data services such as SMS and email. GSM also enables services such as MMS, that is multimedia message service. The primary benefits of 2G networks over their predecessors were the phone conversations were digitally encrypted, which improves security. 2G systems were significantly more efficient on spectrum allocation and wireless penetration. 2G introduced data services for mobile, starting with SMS, picture messages, MMS, etc. This slide shows why 2G replaced 1G. Because of the drastic reduction of call cost, the cost of phone calls got drastically reduced in 2G technologies. Then the availability of wider range of services and improvement of quality of services. Also, SMS became possible in 2G services. Then the same structure of 1G is used in 2G. With the same structure, we can achieve these many things. So, 2G technologies replaced first generation technologies. The main difference between 2G and 1G in technology is from the modulation technique. 1G technology use FDMA, which is frequency division multiple access. In 2G, it use CDMA and TDMA. CDMA is code division multiple access and TDMA is time division multiple access. Time division multiple access permits 8 calls at a time per channel in 900 to 1800 MHz band. CDMA allows 64 calls per channel in the 800 MHz band. That's the advantage. It allows more calls simultaneously. These are the different 2G standards. GSM, which is used all over the world. CDMA 1, which is used in South Korea, Hong Kong and USA. 2G offers a theoretical maximum transfer speed of 50 kbps. In practice, the availability is 40 kbps, which is comparatively good at the time. General Packet Radio Service or GPRS is an extension of GSM and is popularly known as 2.5 generation technology. As denoted by the name, it is based on packet switching compared to circuit switching used in 2G networks. This was a significant improvement over 2G and helped to reduce call cost drastically. GPRS data transfer is typically charged per megabyte of data transferred. This is in contrast to the traditional circuit system circuit switching system where the customer is billed per minute of connection time, irrespective of whether the customer actually use the capacity or not. Another advantage of GPRS is it allows users to remain connected to internet without incurring additional charge and supports multimedia capabilities including graphics and video communication. The deployment of GPRS began in 2000, followed by a new technology, Edge, which is deployed in 2003. Edge enhances the capabilities of GPRS, allows faster internet browsing, and make it possible to use streaming applications. Though this technology provided faster data rates over 2G system, it is called 2.5G because it did not offer the multi-megabyte data rates which were characteristics of 3G system. Next is the third generation technology which is widely used nowadays. The 3G systems are often referred to as IMT 2000, that is International Mobile Telecommunication 2000 systems, since this was a global standard by ITU. The 3G system supports much higher data transmission rates and offer increased bandwidth, which makes them suitable for high-speed data applications. 3G networks are purely data networks, since voice calls are converted to digital data and hence speech is dealt in the same way as data. Three G networks are using a technology known as HSPA, High Speed Packet Access. By incorporating two services, HSDPA and HSUPA. HSDPA is High Speed Downlink Packet Access and HSUPA is High Speed Uplink Packet Access. HSPA is used in more than 71 countries and it supports video calls, voice, telephone, mobile internet access, etc. The HSDPA, High Speed Downlink Packet Access, is used for streaming videos, downloading videos. It's used for internet access, video conferencing, etc. And HSUPA is used for uploading images, videos, blogs, etc. to internet. UMTS, Universal Mobile Telephone System, is one of the 3G mobile systems. UMTS was developed mainly for GSM networks so that these could be easily upgraded to UMTS network. In UMTS, coverage is provided by a combination of variety of cells ranging from in-building picocells to global provided satellites. These are the different standards in 3G technologies. One is UMTS, which is used in European countries, and CDMA, which is used in USA. Next is the fourth generation technology, or we call it as 4G technology. It is more faster than 3G technology. It's around 10 times faster than 3G technology. We can use mobile broadband internet access using USB wireless modems like we are using in Geo5. Then we can easily use the services like IP telephony, gaming services, video conferencing, and 3D television using these 4G networks. The two competing standards with 4G technologies are mobile WiMAX and long-term evolution LTE systems. The next generation is fifth generation, which is not yet deployed, still in the research and development phase. The major characteristics include increased data transmission capability, then connectivity to large number of IoT devices through MIMO, multiple input multiple output technologies. MIMO deploys multiple antennas for transmission and reception, thus increasing the data rate. This table shows the hierarchy of each generations. Like 1G technologies was used in 70s, from 70s to 90s. There were only analog transmission. The standards were NMT, AMPS, and tax. There are no direct support for data. For 2G, it was from 90s to 2000. It improved digital transmission, improved performance by letting multiple users share single channel. The standard use was GSM. Data speed was 9.6 kbps. The next standard is 2.5G technology. It is from 2001 to 2005. It enhanced multimedia and streaming. The standard used was GPRS. It supports 28 kbps or higher data speed. Then 3G network, which was used from 2005 to 2015, enhanced multimedia and streaming video capabilities. The standards used was UMTS, HSDPA, Edge, and WCDMA. The data rate is 384 kbps or higher. Next is 4G technology, which is used from 2010 till now. It supports interactive multimedia, video, wireless internet, and other broadband services. The standards used are LTE and WiMAX. It supports data speed ranging from 100 Mbps or higher. Thank you for listening to the video.